All right, so hello everyone. Hopefully you're all in the right place. So tonight we're going to be talking about interpreting a forage analysis and kind of some of the different things that you may see on a forage analysis and kind of what each of those mean, and go over kind of some of the basics behind that. So first, I just kind of briefly wanted to start by defining the terms forage quality and forage nutritive value, because we often use those very interchangeably, but they really actually have two different meanings. So forage nutritive value is actually the concentration of available nutrients in a specific forage. So the amount of energy, protein, fiber, vitamins, and minerals that are in that forage. And you can kind of think of this like the nutrition facts label on a food that we would see at the grocery store. And so as we go through the different terms on the forage test, we're going to be kind of relating that to that nutrition facts label. Forage quality is really a broader term and includes that forage nutritive value, but it also includes other factors. And what I mean by that is things like palatability. So if a forage contains a lot of nutrients, but the animals are not going to consume that forage, it's not going to do us a lot of good, right? If the animals are not going to eat that forage, even though it may contain, an appropriate amount of nutrients, it's not going to do us any good. It also has to do with digestibility. So how much of that forage is actually going to be digested and make those nutrients available to the animal in their GI tract. Of course, the nutritive value is a component of that. So how many actual nutrients are provided by that forage. And then there might be anti-quality factors or other compounds that could cause problems or toxicities or other issues that we have to be aware of. So forage quality really is kind of the overall extent to which a forage has the potential to produce a desired animal response. And to put that in a little bit more of kind of a visual perspective, here we have a chart kind of showing all these different factors that contribute to the end goal, which is usually our animal performance, right? So all of these different factors contribute to animal performance. Forage nutritive value is just one of those many factors, which include, the forage, the feed, also animal performance is another factor. But forage quality is much broader and includes that forage nutritive value or those nutrients, but also the other things like potential intake, anti-quality factors, and all those different kinds of things. So just keep that in mind. I know I'm guilty of it too, using those terms interchangeably, but really what we're kind of discussing tonight is kind of that more specific forage nutritive value. So when it comes to testing forages, we really have two methods for evaluating them. We have, of course, a visual assessment. There are some things we can tell visually from looking at forages and that we know about, different forages and different species. And then we have the forage testing or forage analysis side of things. And that is kind of what we're going to be focusing on tonight. And that's really what tells us our forage nutritive value. So why do we want to do a forage analysis, or why might this be beneficial? Well, there's a few different reasons. One is if we're purchasing or selling hay, we can kind of assign more of a value to that forage. We can know the nutrient content of that forage. The second is to help us make feeding decisions. So we can work to kind of match the forage quality with the requirements or the nutrient requirements of our animals. We can also use it to kind of formulate rations and determine if we need to be supplementing our livestock or our animals in different ways. And then the final one is to be making storage decisions. So, if we have a limited amount of indoor storage space, we probably want to store our highest quality forage inside to protect that forage and protect that nutritive value. More so than a poorer quality forage. So there's a lot of different reasons behind it, but really, why does a forage analysis matter? So just really quick, if anyone wants to type in the chat, if you had to, look at these two hays and purchase the hay that you see on the left-hand side of the photo or the hay that you see on the right-hand side of the photo, which one would you choose? Anyone want to throw out a quick answer there? The one on the right. Yep. I'm guessing everyone is probably going to say the same thing. Just visually looking at these two forages, we really would probably prefer the one on the right. But if we actually do our forage analysis on these forages and we look at the actual nutrients present in each of those, you can see they're very, very similar. So they both have right around 180 in RFQ, which we'll talk about what that means, right around 19% crude protein, and right around 65% TDN. So you can see that they're actually really similar in terms of forage quality. So just kind of proving the point that, you know, visually appearance is not everything. And that's why we can rely on the forage analysis to really tell us the value of those forages. So we cannot tell our forage nutrient value from the visual appearance, the feel, the texture, the smell. We can really only tell it from a forage analysis. And you may be thinking, okay, well, that's, you know, just me. What about experts or people who look at a lot of different forages or a lot of different hays? They really should have a better idea of knowing which ones are higher or lower in quality, right? Well, this is a mini experiment that was done at one of our national forage conferences or conference meetings. And they asked all of the experts who were attending that meeting. So, you know, there were some producers, there was extension agents, there was industry personnel. They asked them to rank each of these hays, which you can see here, A, B, C, and D, based on their forage quality. So just rank them from best to worst. And what the bars are showing you here is the actual forage quality, so the real value of each of those forages. So you can see that hay D was the best, hay A was actually the worst. And here's the percentage of people who said that each of those hays was number one. So 45% of people attending that meeting thought that hay A was actually the best, when in fact it was the worst. So just driving the point home that we do really need to rely on our forage analysis to know that nutrient value. So if you've never seen a forage analysis before, here's kind of a picture of an example of what one might look like. And there are a lot of different things included on that forage analysis. And what we're going to go through for the rest of the presentation is just some of the major things that we see on that forage analysis, and talk about what those different terms mean and how we can relate that back to kind of our animal nutrition and our planning. And again, as we go through each of these, we'll kind of be relating it to that nutrition facts label, just to give you kind of a reference to something that you might be a little bit more familiar with looking at. So forages actually contain all 6 of the major nutrients that livestock require. So carbohydrates, protein, fat, vitamins, minerals, and water are all present in forages. And we're going to talk about kind of the percentages of each of those as we go along. And then also the fact that carbohydrates can be further broken down into structural or fibrous component and non-structural, which is kind of like our sugars and starches. So first, starting off with that water component. So when we look at a forage analysis, there's always, you know, usually 2 columns, one for dry matter and one for as fed. And dry matter is basically the percent of the forage that is not water. So if we were to take all that water out, we were to dry that forage down, it would be the whatever amount was left. And pasture, because it's generally in its fresh state, contains a lot higher percentage of water. So it conversely contains a lot lower percentage of dry matter compared to hay, which we've already dried down and removed a lot of that water. So it has a lot higher percentage of dry matter. So you can see here at the top of this, I just zoomed in on a forage analysis. You can see the percents listed for moisture and dry matter. And if you add those up, it's always going to equal 100% because they're just the inverse or the opposite of each other. But the important thing with this is to remember to always look at that percent dry matter column when we're looking at our different nutrients on our forage analysis. And the reason we do this is because it allows us to compare things on a more equal basis. So you can kind of use, you know, grapes and raisins as an example. So grapes would be like our fresh forage, like our pasture. They have a much higher water content versus raisins have been dried down, that some of that water, that moisture has been removed. And as a result, they're more concentrated. So if we did a half cup of grapes versus a half cup of raisins, you can see there the calorie difference between those two, just because we've removed that water component and concentrated those nutrients in that raisin. So that's kind of like our hay. So looking at everything on a dry matter basis allows us to compare our different feeds on a very equal basis. So here you can see in the top row, we have pasture as fed. So those are the nutrient values for that pasture. And in the bottom, we have grass hay, also as fed. And you can see the difference there in the dry matter, the protein, and the other fiber values. If we compare them on an as-fed basis, they look very different, right? It looks like the protein is way better in the grass hay versus the pasture, and the other nutrients are really different as well. If we actually compare them on a dry matter basis, they're actually the same. So the difference was that pasture is more diluted because of that water content. So when we remove that and compare them on an equal basis, they're actually the same. So just remember to look on that at that dry matter basis when we're looking at a forage analysis. So there's our water, the first major nutrient, and there's just kind of, again, those percentages for averages that are present in pasture and hay. So the rest of the nutrients, we can kind of divide them into structural and soluble components. So structural components are those that are present in kind of that cell wall area. So they're more fibrous, they're a little bit less digestible. They provide the strength and support that that plant needs to grow and maintain itself and remain upright as it continues to grow. We also have soluble components, which are usually found inside the cell of each of those plant cells. And these are more easily digestible, more readily available nutrients to our animals. So we'll talk about, first, we're going to go through kind of the structural components. So the major structural components that are present in those plant cell walls. The first one is neutral detergent fiber. NDF, as it's abbreviated to, is including basically all of those fibrous primary cell wall components. So we have cellulose, hemicellulose, and lignin all together to make up our neutral detergent fiber. So it's really like all of the fiber present in that forage. So it has that direct relationship with fiber. As we have more NDF, we have more fiber content in that. So we can kind of relate it to what we see on the human nutrition labels, that dietary fiber line that's on there. It's kind of a measure of the total fiber present in that food. And the reason we look at NDF is it does have an inverse relationship with intake. So as something is more fibrous, it has a higher fiber content, the animals tend to get full, they have more gut fill, so they'll eat less of it. So we see that inverse relationship between the NDF and the intake. If we kind of break that down and go a little bit more in detail, the next level down is acid detergent fiber, or ADF. And this is just the cellulose and lignin. So we've taken the hemicellulose out and we have just the cellulose and lignin components. And this represents the least digestible portion of that plant cell wall. So again, it is associated with fiber. So the more ADF we have, the more fiber we have. But it also has a relationship with digestibility. So the more ADF we have, the less digestible our forage is going to be. And then finally, if we go, one more level down, we have lignin, which is basically kind of the skeleton, if you will, of that cell wall, kind of what provides the structural support for that plant. And it's basically, for the most part, indigestible. So again, it is associated with the fiber content, but it's also tied to that digestibility because it's the most indigestible of all of the things within those forages. So those were all kind of under that structural or that fibrous category. And there's just kind of some average values for what we see in forages. You can see there's a big range in the percentage of NDF and ADF that we can see, especially NDF. And that's just because of a lot of different things, forage maturity, different species, all those different factors play into the amount of fiber present in our forages. So if we switch from the structural components to the non-structural components, these are our more simple carbohydrates. So sugars, fructans, starch, those are all things that are really readily available as an energy source, and they are rapidly and easily digested by the animal. So they're all things that are found inside those plant cells. And if you don't see non-structural carbohydrates listed on the forage test, some labs may or may not have that listed. You will see other terms that make up that. So water-soluble carbohydrates, ethanol-soluble carbohydrates, and starch. And non-structural carbohydrates is really actually just the sum of our water-soluble carbohydrates and starch. So it kind of includes all of those simple carbohydrates. The WSC, ESC, and starch are individual fractions within that. And if we compare this to what we might find on a food label, we can most closely relate it to the total sugar content. So we see kind of total sugars on our nutrition food labels, which is very similar to kind of the non-structural carbohydrates with our forages. As far as average concentrations, we usually see somewhere in the range of 8 to 20% non-structural carbohydrates in our forages. Again, this varies based on a lot of different factors. We'll see a list of some of those a little bit later in the presentation, but we can see that variability in non-structural carbohydrates in our forages, but usually somewhere in that, 10 to 15%, maybe up to 20% on average. The next component, which is also inside the cell primarily, is protein. So protein provides, of course, those essential amino acids. So remember that livestock don't have a protein requirement, they actually have an amino acid requirement. And which amino acids are most limiting will really depend on our livestock species. They've done a lot of research and figured out which amino acids are usually most limiting for our different livestock species. So again, it's, in the inside of that cell usually, and for human nutrition, we can most closely, of course, relate this to the protein that we see on our food labels. The key with protein, or the thing to remember, is protein is actually not directly measured. We don't have a good laboratory analysis to measure protein in itself. So it's actually estimated based on the nitrogen content of the forages. So we have laboratory procedures that allow us to measure the nitrogen content of our forages. And then the crude protein is just measured by multiplying the nitrogen by a factor. They've figured out, on average, the amount of nitrogen that makes up protein and done the conversion that way. So just remember that it's not a direct measurement. And because it's not a direct measurement, it actually includes both our true protein, so our actual protein, as well as some non-protein nitrogen, like urea would be an example of something that's a non-protein nitrogen. So it's kind of our best measurement at the moment for most of our livestock species, but just keep that in mind that it is a little bit of a rough measure. As far as protein content in our forages, we usually see anywhere from kind of 6 to 25, maybe even a little higher percent on average in our forages. So, 10 to 20% is kind of usually the average protein content that we can expect to see in some of our forages. The next nutrient is fat. So fat, of course, is a very high density source of energy. So fat, is composed, like protein is composed of amino acids, fat is composed of fatty acids. And the reason it's so energy dense is it contains actually 2.25 times more energy than carbohydrates. So it's really our most energy dense nutrient. Fat, of course, is primarily found in the interior of that cell. So it's one of the more soluble components, but actually forages really only contain a very small amount of fat. So we don't see a huge amount of fat present in our forages. It's usually just a very small percentage. The way fat is determined in the lab is through ether extraction, or EE, you may see it abbreviated. That's how we determine our crude fat measurements. And because it's crude, sort of like the crude protein, it includes a couple of other things in addition to kind of our true triglyceride, fat sources. So it also includes some other lipids like some pigments, some esters, some aldehydes that are present in the plant, along with those triglycerides. And if we compare that to our human nutrition label, we of course have kind of a total fat measure on there. So that's the most closely related measure we see on our human nutrition labels. As far as fat percentage, I mentioned that it was very small. We usually only see maybe 2 or 3% fat in our forages. So really our livestock they don't consume a lot of fat, and what they are getting is usually not from the forages. So vitamins and minerals, we're just going to kind of do very briefly because there's a lot of things that affect vitamin and mineral content, but vitamins, of course, are, an organic substance that our animals need, just like we need for proper nutrition. And they're a part of many, many metabolic processes that go on throughout the body. So required for normal function. Vitamins can be broken into fat soluble and water soluble. So for fat soluble, we have vitamin A, D, E, and K, and water soluble includes all of the B vitamins as well as vitamin C. And of course, we as humans have vitamin requirements, and you'll see a lot of similar requirements between kind of what we require and what our livestock require. Livestock do have the advantage that they can actually synthesize many of the vitamins that they need. So the microbes that are present in the rumen of those cattle can actually provide a lot of vitamins to that animal. And then they can also get vitamin D from sunlight, just like we can. So they're able to, as long as they're, getting access to some sun, they're able to synthesize vitamin D in that way. So forages do contain a lot of those vitamins that the livestock can synthesize, but they also contain some of the ones that they cannot. So vitamin A and E in particular are ones that are present in forage, especially fresh pasture, that are required by the livestock because they're not able to synthesize them themselves. One thing to keep in mind is as we're harvesting hay and storing it or any stored feed, the vitamin A and E levels tend to decline over time with storage. So we can't really rely on stored forage as a good source of vitamin A and E like we can with fresh pasture. For the minerals, minerals are also are inorganic nutrients as compared to organic. But again, they are also required for proper nutrition, just like we have requirements for minerals, our livestock do too. So they're required for many of our normal metabolic processes. And here's just a list of some of the major minerals that are required. So the major ones are, or sometimes referred to as macro minerals. You can see on the left-hand side of that table, that just means that they're required in slightly higher amounts compared to the micro minerals or trace minerals, which are on the right-hand side of that table. And that just means that those are required in smaller amounts. And like I said, we have mineral requirements too. So we'll see minerals listed on our nutrition facts labels in the grocery store. Forages do contain a lot of essential minerals, but this is really variable and site specific. So it depends a lot on what minerals are present in the soil, because the plant can then, take up some of those minerals and have it present in the forage. So it's a little hard to say, the mineral concentration of our forages on average, because it is so variable and so dependent on the site and the soil and what plants are growing and all those different things. As a general rule of thumb, our forages are not a great source of sodium chloride, so salt, which is why we oftentimes provide salt to our livestock. And they're not also usually a great source of some of our trace minerals. So things like copper, zinc, manganese, selenium can be deficient in our forages, both fresh and harvested forages. So that is something that we need to watch out for and be making sure that we're providing that salt and those trace minerals in another form to our livestock to make sure we're meeting that requirement. So this is just a zoomed in screenshot of one of those forage analyses. And I just wanted to put this up there to show that with a basic analysis, so kind of the standard, no extra things added, they usually provide values for calcium, phosphorus, magnesium, potassium, and sulfur. So some of our major minerals. But if you really want to know more about the mineral content of your forages, you have to select, more information when you're submitting that sample to the lab. So there's our vitamins and minerals. Vitamins are fairly variable. Remember that some can be lower in our hay. Minerals are also variable, and remember that they're fairly site specific, and we do need to be providing salt and those trace minerals in some form, so we're meeting those requirements. So those are kind of the major nutrients, but you might notice that there's something missing, and that would be kind of our energy, right? So livestock can get energy just like we can from carbohydrates, protein, and fat, and that includes both structural and non-structural carbohydrates. So those are all of our kind of energy sources for our different livestock. And we do have some measures of energy that we see on a forage analysis. So one example is total digestible nutrients. So this is a measure of the energy value in a feed, and it's designed to reflect the available energy to that animal after digestion. So how much energy is able to be digested and absorbed by that animal for them to use. And we have something similar on our nutrition facts label, and that is calories. So that's how much calories or how much energy we can get from our food. TDN is one measure of how much energy our livestock can get from their forages or any feed really. This one is also not measured directly, but it's done based on a whole bunch of calculations based on the energy that might be available from protein, fat, carbohydrate, and digestible fiber. So that brings in that non-structural and structural carbohydrates. So they do a bunch of calculations, measure all those other components, and then calculate the energy based on that. There are different calculations based on the type of forage. So there's a different equation for legumes compared to grasses. So you do need to select, what you have, or if it's a mixed stand, which is maybe more of the dominant species, to help with that prediction for that TDN. So think of TDN as kind of an energy or a calorie measure. Another option is using the net energy system. So this is just a different way to measure energy in forages. And again, it's a sum of energy from carbohydrates, protein, and fat. So it's similar to TDN in that way. But it accounts or attempts to account for different loss pathways. So we know that as animals are, consuming these forages or feeds in general, we have some loss through fecal losses, gas, heat losses, and the net energy system is designed to better account for those. So it starts with the digestible energy, which is the energy available for use after fecal losses. So how that works is we have gross energy, which is basically like the energy potential of that forage. So how much energy could we get from it if we could extract everything and have no losses? If we subtract out energy that's lost in the feces, so any portion of energy that wasn't fully digested or was maybe bound to something, or it moved through the GI tract too quickly, so we weren't able to get everything from it, those are fecal energy losses. And if we subtract those from our gross energy, we get digestible energy. So you can kind of think of it like measuring what goes in at the front end is our gross energy, measuring what comes out in the feces, and the difference between those is our digestible energy, which is theoretically all the energy that was absorbed by that animal. And you see a horse there because this is really the measure that's most common in the equine industry. So when we're balancing equine rations, we rely primarily on digestible energy as our energy measure. We can take that further and move further down and account for more losses. So from digestible energy, if we account for the gaseous and urinary losses, that ends up as metabolizable energy. And from there, if we count for the heat increment, which heat increment is, the amount of heat produced through that digestion process. So as those animals are digesting their forages and their feed, there is some heat that's produced. And that's, of course, helping to maintain that animal's body temperature. But that heat increment takes some energy to maintain that body heat. And so if we account for that loss, then what we get is net energy, or NE. And net energy is basically the energy available to that animal to support either maintenance, so regular body function, and also production. So whether that's growth, whether that's milk production, we can divide that net energy component into energy used for maintenance, growth, or even lactation. And the equine industry, like I said, relies on digestible energy primarily. The cattle and the swine industry are a little bit further ahead, and they use actually net energy, or even net energy for maintenance or production. So they're a little bit further down. So you may see some of these various energy terms on that forage analysis, but recognize that all of these gross GE, DE, ME, NE are all part of this net energy system, and they're just trying to account for those different loss pathways. So that's kind of our two major systems that we use to measure energy. If we look at actually how much energy is present in forages on average, I picked TDN to look at for this example. It's usually somewhere in the 55 to 75% of the total. So we're not getting, of course, all of the energy potential. There is some losses and some other things occurring, but that's kind of just a ballpark average for what we see in our different forages. So the one other thing that's not really necessarily a nutrient, but that you might see on a forage analysis is digestibility. So we have a few different terms looking at digestibility, and that's just trying to get to basically how much of that forage is able to be digested by that animal. So we have dry matter digestibility, or DMD, as an example, and it's basically just the extent of the total dry matter, so everything but the water, how much of that is able to be digested. And there's a few different ways we can measure it. In vivo is actually measuring it in the animal. So again, measuring kind of what goes in, measuring what comes out, and taking the difference as what was actually digested and absorbed. We can measure it in situ, which is when you see kind of those cannulated cattle or cannulated livestock. They're using little bags that they can, put in the rumen and actually kind of get a measure for digestibility in that way. Or in vitro, there is some lab equipment that we can get used to estimate digestibility using laboratory equipment. And the most crude measure is estimating it from ADF, but that's kind of, we've kind of moved past that, at least in most of the laboratory analyses. And one of the in vivo, in situ, or in vitro measures are preferred over just doing an estimation from ADF. Another common measure for digestibility is looking at how much of that fiber is digested. So we talked about NDF as being the total fiber content of that forage. We can measure how much of that fiber is actually able to be digested. And usually for this, it's reported by a certain time period. So if you see like NDFD 48, that means the amount of NDF that was digested in 48 hours. And you may see, NDFD 32, NDFD 72. There's different, time periods that go along with that, but 48 is usually kind of the standard that's used for NDFD. So it's just telling us how much of that fiber is actually able to be digested and broken down by the animal. All right, so the last term that we're going to talk about is relative forage quality. And this is basically a term that tries to combine all these different quality measures into kind of one value that we can use to compare different forages. So if we ask ourselves, what is high quality forage? We know we need something that's highly digestible, right? So we want those nutrients to be broken down and available to the animal. So we want a lot of energy, we want high digestibility, but we also need something that's readily consumed. So it has high intake, not too high of fiber. We're going to slow down the intake of our animals. And relative forage quality tries to account for both of these factors. So it's a single measure that kind of represents our overall forage quality. And really its best use is allowing us to compare across different forages with one number rather than having to look at protein and energy and digestibility and all those other things, giving us a single number that we can use to make quick comparisons. So again, this is not something we can directly measure, but it is calculated based on a bunch of the other values that we already talked about. So it relies on TDN, total digestible nutrients, to kind of account for how much energy is there and also how digestible that forage is. And it also accounts for dry matter intake, which is largely based on that NDF value. So we know that there's that inverse relationship between the amount of fiber and the amount of intake. So we're kind of lumping all those together into one quality measure. And so if we kind of talk just a little bit about RFQ, for comparison's sake, here on the left-hand side, you can see we have a 25-pound pile of alfalfa forage. And you can see the volume there, measured of that pile. And on the right-hand side, we have a 25-pound pile of Bermuda grass. So same amount of weight in each of those piles, but you can see that the volume of that Bermuda grass pile is a lot bigger. So it took a lot more forage to get to that 25 pounds. So we have a bigger volume. If we think about, okay, which of these probably has a higher forage quality value? I'm guessing most of you are going to say the alfalfa pile right away, right? If we actually measure the TDN or the energy content of those forages, we see a higher TDN we see a very similar TDN in both of those piles. Okay, that's interesting. They both contain a similar amount of total digestible nutrients, so they contain a similar energy content. But the relative forage quality, or RFQ, is a lot higher for the alfalfa. So kind of confusing, right? We have the same energy, so why is the quality higher? Well, the alfalfa pile has the ability to have a much greater intake. So the livestock are able to consume more of that, and therefore they consume more total energy. And to kind of help you visualize that a little bit, we can kind of think of it like if we had a plate of French fries versus if we had a plate of bell peppers. And we can, figure out the calories of each of those plates and put the same amount of calories on both plates, which is what you see here. So those two plates are equal in terms of calories, which is again kind of our energy measure, so similar to TDN. So we have the same amount of calories, same amount of energy, but the plate of French fries is a lot smaller than the plate of peppers because we have that energy in a more dense form, right? So I don't know about you all, but I would much more easily be able to eat that small plate of French fries than that massive plate of bell peppers. I don't think I'd be able to finish all of that. So we can kind of think of it in the same way. So we have the same amount of energy in each, but the quality of the French fry plate is higher because it's factoring in that intake as well. So kind of one measure to kind of lump all of these different factors together, and that's what we use relative forage quality for. So I know I threw a lot of different things at you, a lot of different nutrients that we talked about, a lot of different values. Usually these are my recommendations for, if someone's just getting started or just looking at their first forage analysis and they kind of want a place to start. These are kind of the three things that I would look at first. So fiber, so neutral detergent fiber, kind of that total measure of fiber. Of course, we want something that's not too fibrous because we know that will affect their intake. So we want to provide enough fiber for, good GI tract health, but we don't want to provide too much where we're going to be restricting intake. So an NDF less than 50% is usually on the lower end of the spectrum, and NDF greater than 60% is usually on the higher end of the spectrum, and then in between those is kind of more moderate. And that's primarily for grasses. So legumes will be a little bit lower. They contain a little bit less NDF on average than our grasses do. For energy, so that's the next thing we might want to look at. We can look at any of those different energy terms. So total digestible nutrients, digestible energy, or net energy. If we pull out again TDN as our example, TDN less than 55% would usually be considered something that has a lower energy value. A TDN greater than 65% would be considered something that has a higher TDN value or higher energy value. And then in between those is again our moderate kind of value. So and then protein, we want to of course meet our protein requirements or amino acid requirements for our livestock. 10% or less is usually considered more of a low protein forage. 14% or more is usually considered more of a high protein forage. And then of course in between there again is kind of the moderate level. So this kind of just gives you a really rough ballpark numbers to start with. You might ask, well, what about RFQ? Well, that's actually not, an essential nutrient. It's not really a nutrient. It's kind of a measure of all these different things combined. So there's not really a nutrient requirement or a value that we need to hit there, but it is really useful when making those comparisons or comparing different forages. That's kind of a good place to start. But then remember that there are a huge number of factors that affect our forage quality. So forage nutrient content varies a lot based on all of these different things that you see listed here. Maturity is a big one, differences in forage species, soil fertility, the management conditions, all of those things can affect the forage quality and the amount of nutrients present in those forages. Some of these we can kind of see visually, how mature was that forage, how leafy is it, how stemmy is it, what type of species do we have there. Some of them are a little bit more pertinent to kind of management, so how that forage was managed in terms of soil fertility, how it was handled during harvest. So we can use these other things to kind of assess or rely simply on our forage analysis to tell us, the nutrient value of that forage. So the final thing that I wanted to address was, say we have two forage analyses here and we're kind of looking at them both and we're wondering, okay, which one of these should I feed? Which one should I use? How do I know what to do with that? Well, you can use all those values that we just talked about, but then also remember that our nutritional needs will vary based on our animals. So all of these different factors affect the nutritional requirements of our animals: body weight, body condition, age, breed, level of production, environmental conditions, level of activity. All of those play a role in the type of forage and the type of feed that that animal needs, right? So, as an example, here we're looking at relative forage quality. The relative forage quality, or the quality that an animal needs for, say, a dry cow or an idle horse, is going to be very low. They're going to be on the low end of the spectrum. If we bump up to maybe a lactating beef cow or kind of that moderate, moderate age, not super young, but still growing heifer, they might fall kind of more in the middle. And then of course, at the very top end of the spectrum, we have our lactating dairy cows that have just calved and are in their, first 120 days of milk, or those really young growing calves might also fall in that spectrum. So consider the type of animal and the life stage when you're thinking about what type of forage quality that livestock requires. So for an animal at maintenance, that would be, say a dry, mature beef cow, or maybe a bull not during breeding season. It's just kind of at maintenance. They need something that's a little bit higher in fiber, a little bit lower in energy, and a little bit lower in protein. They don't have a high energy or protein requirement at that life stage. If they're in kind of that moderate category, that might include a beef cow that's pregnant, but hasn't calved yet, or maybe an animal that's growing. They might need more of a moderate fiber level, moderate energy, and a moderate protein. They have a little bit higher requirement than those animals at maintenance. And then at the top end of the spectrum, we have our, lactating, growing, and finishing animals. So they need something that's, lowest in fiber, highest in energy, and highest in protein. So that would be kind of a cow who's just calved and is at the peak of her lactation, or that really young growing animal, or that animal that we're trying to finish and, put our finishing weight on. So those animals have that highest energy and protein requirement. It also, is affected by size or body weight. The bigger an animal is, the more frame size they have, the more they're going to need to support that frame size and maintain that body condition and that body weight. Environment plays a role. So when it's really cold outside and those animals have to burn a lot of energy to stay warm, that's going to bump up their nutritional needs. And body condition score. If we have an animal that's thin and maybe needs to put on a little bit weight, they're going to have a higher energy requirement and a higher nutritional need compared to an animal that's already at a perfect body score or a good body score. So the final thing is to just evaluate and adjust. So if you, see based on body condition score, based on body weight, based on the performance of the animal, health or disease rate or incidences can make a difference, feed intake, we can use all of those different clues to adjust our nutrition program and adjust what forages might be the best fit for our different livestock at our different life stages. So to kind of wrap all of that up together, we know that forage testing allows us to do that accurate quality assessment and actually allows us to tell what nutrients we have present in our forages. We know that when we're looking at forage quality, if we are looking for a place to start, we can start with things like NDF, TDN, and crude protein for our major kind of fiber, energy, and protein values. We can use RFQ to make comparisons across different species or across different fields, different lots of hay. Remember that we have a lot of factors that influence forage quality. So maturity, leafiness, the forage species, all those things play a role in forage quality. But it's really important to select a forage that matches our animal's needs and then evaluate and readjust that as needed. So that was it. That was everything that I have. Hopefully that wasn't too many nutrients and terms and things thrown at you, but if anyone has any questions, happy to answer those.